So this is a continuation from 5.3. We are moving on to the half angle formulas, okay? These three formulas are very similar. Notice on all three of them, we have a plus or minus and a square root. So the plus or minus will be determined based off of which quadrant we are in, okay? I'll show you that when we start off our first example. All three have a square root, okay? And then the numerator for sine is 1 minus cosine theta and then over 2, okay? For cosine, it's the same exact thing, but a plus, 1 plus cosine over 2. And then tangent, remember that back from chapter 4, tangent is sine divided by cosine. So we have the sine numerator, which is 1 minus cosine, over the cosine numerator, which is 1 plus cosine, okay? Now, these little symbols are alphas, okay? It's just another variable for an angle like theta is and beta. So here, half angle, it's going to be theta, alpha over 2, and then that's the alpha we're going to place here, okay? So please, again, remember that these formulas, the goal is to use the one that we can match up to our unit circle. So if I look at my first example, notice that it says sine of 105 degrees. I don't have 105 degrees on my unit circle, okay? So to begin with, 105 degrees is in between 90 and 180, which means that 105 lands in quadrant 2, okay? If I'm in quadrant 2, my signs are negative. Let me get my white out. All right, I'm sorry about that. So quadrant 2 is negative, positive. And if what I want to find is the sine of this value, I know sines of quadrant 2 are positive. So at the end, when I apply the formula for sine, instead of putting plus or minus, I'm just going to pick the positive one, okay? So my answer is going to be positive, okay? Next step is if my formula has an alpha over 2, and this question says 105, I need to figure out what my alpha is going to be to plug into my formula. Okay, well, this is simple algebra here, solving for alpha. I'm going to multiply the 2 to the other side. So I have alpha equals 2 times 105 is 210 degrees. This is the alpha that I'm going to place in my formula. Okay, so next step. It's a positive, so if you'd like, put the positive so you know you didn't skip that step. My formula is 1 minus cosine. I found out that alpha was 210. 210 is on my unit circle over 2. Okay? So now, next step, at 210, what is my ordered pair? Okay? Or if you have it memorized, which if you're in my class, please make sure you have that unit circle memorized. You know that cosine of 210 is a negative radical 3 over 2. Okay, so I have a square root of 1 minus negative radical 3 over 2. All over 2. Okay, so this next step that I'm going to show you happens every single time you solve one of these questions. Okay. You could do this subtraction, or which will become addition, get common denominator, then keep, change, flip. It is definitely an option. It's just lengthier. The shortcut that I'm going to teach you is that anytime you have a complex fraction, meaning a fraction within another fraction, that extra denominator, which in this case is a 2, if you multiply it to top and bottom, you will automatically eliminate that complex fraction. Okay, that 2 is going to get multiplied to every single term in the numerator and the denominator. I'm going to take it slow this first time, but the process is going to be the exact same every single time, okay? So 2 times 1 is 2. A negative and a negative make a positive. When I multiply a 2 here, I get 2 radical 3 over 2. And then 2 times 2 is 4. Notice I always fix this radical because it does go all the way to the denominator. So the whole point of this is that these 2's cancel out and I no longer have that extra fraction. Okay? So I have 2 plus radical 3 over 4. all inside of a radical. Okay? Now, remember that radicals can be split with numerators and denominators. And then I can say that the square root of 4 is just 2. Okay, and that is my answer. So a few things that are always going to happen in these questions, okay? Right here, multiplying this 2 over 2 will always happen in this question, okay? And this 4 becoming a positive 2 will always happen, okay? Because my denominators in the formula is always a 2, and since I'm multiplying by 2 over 2, this will always become a 4, and the square root will always turn it into a 2. Okay, so just some things to look out for. Let's try another one. Cosine of 5 pi over 8. 5 pi over 8 is not in my unit circle, which is why I want to change it. Okay? For starters, 5 pi over 8 is in quadrant 2. I know that because 5 over 8 is more than a half, but less than a whole. Okay? In quadrant 2, my signs are negative, positive, and since I'm working with cosine, okay, my answer is going to be a negative. Next step, find out what alpha is. If in the formula it's alpha over 2, I set that equal to 5 pi over 8, multiply the 2 over, I get 10 pi over 8, which reduces to 5 pi over 4. And this is in my unit circle. So now, cosine formula is plus or minus. I said it was going to be a negative. Square root of 1 plus cosine of what my alpha is. Now it's a value I can find on my unit circle. All over 2. Okay? So I have negative square root 1 plus cosine of 5 pi over 4 is a negative radical 2 over 2. Now the next step is the one I told you would happen every single time. Multiplying top and bottom by 2 over 2. Those 2's get multiplied to every single term. Remember, the purpose of multiplying that 2 is so that it cancels with this denominator. Okay? So now I can go straight to saying negative square root 2 times 1 is 2. A positive and a negative make a negative. This 2 is meant to cancel this 2 out, so I'm left with that radical 2 in the numerator. All over 2 times 2 is 4. Okay? And now the last step that I told you always happens, this square root of 4 becomes a 2. Negative square root of 2 minus square root of 2 over 2. And you're done with this question. 2 more questions here. Let's look at cosine of 105. So 105 is not on our unit circle, but it is in between 90 degrees and 180 degrees. So we know that this lies in quadrant 2 again. Quadrant 2 is negative comma positive. So because we are looking for cosine, our answer is going to be negative. Okay? So next step is to find out what our alpha is. I know inside the parentheses is alpha over 2, and this question is 105. We already worked this out in an earlier question. We multiply the 2 over, and alpha equals 210 degrees. Okay? So now I know my answer is negative. My formula has the square root. Cosine has 1 plus cosine of my alpha, which is 210 degrees, all over 2. Okay? Next step is to go to the unit circle. Cosine of 210 degrees is negative radical 3 over 2. So we have 1 plus negative radical 3 over 2, all over 2. that next step that I tell you happens every time. Multiply 2 over 2. Okay, so we have 2 times 1 is 2. A positive and a negative is a negative. The whole point of multiplying this 2 is to cancel this 2 out. So I'm just left with that. Radical 3 over 2 times 2, which is 4. Don't forget your radical and the fact that we said this answer is going to be negative. Okay? And then my last step is that a radical 4 is a 2. Okay? All right, last one. Let's see a tangent. We haven't seen one of those yet. So 5 pi over 8, we already talked about it. We know it's not on our unit circle, but because 5 over 8 is more than a half, okay, which is 90 degrees up top, but less than a whole, we know that it lies in quadrant 2. In quadrant 2, we have negative, positive, okay? And we know that tangent is dividing sine and cosine. So when I divide a positive and a negative, I get a negative, which means my answer is going to be negative. Next step is to find out what alpha is. If alpha over 2 is what should be in the parentheses, we equal them. Multiply that 2 over. And let's reduce so we can recognize the value that is on our unit circle. 5 pi over 4. Plug that into the formula. Again, my answer is going to be negative. And I have 1 minus cosine of 5 pi over 4 over 1 plus cosine of 5 pi over 4. Okay. Go to my unit circle. Cosine of 5 pi over 4 is a negative radical 2 over 2. Always make sure that your notation of your radicals extend to the denominator. Same step as always, multiplying that 2 over 2. Okay. So now 2 times 1 is 2 minus, the whole point of this 2 is to cancel out that one in the denominator. So I just am left with a negative radical 2 over 2 times 1 is 2 plus, again, cancels out that denominator. Here we do not have a step of cleaning a denominator of a radical 4 just because we don't have one. All I'm going to do is fix my signs. Do not worry about a radical inside of a radical. That is okay. I end up with 2 plus radical 2 over 2 minus radical 2. And we are done. Oop, I almost forgot my negative. And we are done with this question.